Good morning, students. Welcome to the physics class. So, our today's topic is position time graph. So, students, first of all, what is graph? So, students, graph is basically a pictorial representation. We can say a picture which is showing the relationship between any two quantities. So it gives us the idea how the quantity will vary if we change any of the two quantities. So students, in this we can determine various types of graphs. In this we have one is position time graph and one is velocity time graph. Today we will discuss position time graph. Basically in this, on y axis we have position, that is x, or we can say displacement, and on x axis we have the time. So students, in this we see the relationship between displacement and time. So students, if you see the graph for a stationary object, it will be a straight horizontal line. So in this you can see that when time is 0, then position of the object is x naught, and as the time changes there is no increase or decrease in the displacement. That is, initially the displacement is x naught and finally also the displacement is x naught. So we can say if there is no displacement then there is no motion, so object is at rest. Now students, next we have graph of object which is in uniform motion. So it is a basically straight line but not horizontal or not vertical. It is a straight inclined line. So students, in this if you see, this is x2 minus x1 and this is t2 minus t1. So this is the change in displacement, this is the change in time. So this graph gives us that its slope will tell us. So how we can calculate the slope? It is basically equal to tan theta. So in this triangle, if you see, what will be the tan theta in this triangle? Tan theta will be equal to QR upon PR. So here what is QR? x2 minus x1, and what is PR? It is t2 minus t1. So what is x2 minus x1? It is basically displacement. When the time was t1, the object was at x1, position x1, and when the time is t2, then the object changes its position and reaches at x2. So students, x2 minus x1 is the displacement and t2 minus t1 is the time. So this is displacement upon time. So what is this? Displacement or time is known as velocity. So slope of position time graph gives us the velocity. Hence the slope of the position time graph gives velocity of the object. Now students, here we have third graph. It is uniform accelerated motion, means in that velocity was not changing, but in this velocity changes, because you can see easily that initially the slope is less, but as we move along the line the slope increases. So students, in this way we can say that if slope is increasing, then velocity is also increasing, because slope of position time graph gives us velocity. So in this way, if velocity is increasing, then we can say this is a accelerated motion. So students, these are some position time graphs. We have three types of graphs. One is horizontal line, which gives straight line motion, straight when the object is stationary. Second graph we have for the uniform motion, that is when there is no change in velocity. And third graph we have for the accelerated motion. Now next we have velocity time graph. So basically velocity time graph is between velocity and time. So in this we have the graph for uniform motion when velocity is not changing. So here we can say that line is horizontal. So when time is 0, velocity is v. When time is t2, velocity is v. When time is t1, velocity is v. V means velocity is not changing. So students, if we have straight line, horizontal straight line, then this graph gives us uniform motion. Now we can calculate the area of rectangle ABCD. So area of rectangle ABCD is equal to AD upon DC, AD into DC. So here AD gives us velocity and DC gives us time. So velocity into time is displacement, we know. Hence we can say that the area of a velocity time graph gives us the displacement. So in this way we have next we have graph number 2, that is this is graph for uniform acceleration. As you can see that it is a inclined line, straight inclined line, so slope is not changing. So what is slope of velocity time graph? We can see here slope of velocity time graph gives us acceleration. So slope is not changing, so that's why we can say acceleration is also not changing. So this is uniform acceleration. Now these are the two graphs. Now we will discuss further that how we can calculate the distance from the velocity time graph in the next video. Thanks for attending class.